Welcome back, Calc. We are going to be finding relative extrema by hand today. So these are your relative, also known as your local, mins and maxes. I have the checklist on the screen. You know what to do from here. So before we get started, I would just do a little bit of a review with you. You don't need to write anything yet. But if I were asking you to find the x-coordinates of the points of inflection, which derivative would you, the sign of which derivative would you want to analyze? The first derivative or the second? You would make a number line with the second derivative, right? So you would take the second derivative, set it equal to 0, make a number line. Wherever the second derivative changes signs, the original function, f of x, changes concavity. And wherever we have a concavity change on f, that is called a point of inflection, okay? So let's try this one. I've already given you f double prime, so I've done that first part for you. Now can you make a number line and decide where the points of inflection for f are? Hit continue when you're ready to see the answer. So we have points of inflection only at 3 and 5, not at -4, because of that even multiplicity, right? So that is going to force my sign to stay the same at -4, whereas at 3 and 5, the sign of f double prime will change. Okay, so a little bit more review for you here. Can you draw me a function that is both increasing and concave up? So something like that, right? Try the next 3 on your own, hit continue when you're ready to see some possible answers. So here are different pieces. So increasing concave down, decreasing concave up, decreasing concave down. I really just want to hit home that you can, be both increasing and concave down. Just because a function, for example, is concave down does not mean it's going to look like a perfect parabola that's opening down, okay? So it could be just maybe segments of that, if you will. Okay, so last review aspect before we get into the lesson. So I've got this graph of y equals f of x here, and I would like for you to tell me whether f of a, f prime of a, and f double prime are all 0, positive, or negative, okay? So for f of a, what do you say, 0, positive, or negative? Yeah, f of a, that's the graph, the y value there is 0, right? Okay, what about f prime, 0, positive, or negative? F prime is positive, right? Because f is what? Because f is increasing. Okay, what about the second derivative at x equals a, 0, positive, or negative? That is going to be negative, and what's our justification? Since f is concave down there. Remember, second derivative sign tells you the concavity, first derivative sign tells you the increasing, decreasing behavior of f. Okay, so let's look at the lesson. So today we're looking at relative extrema. Another word for relative that you might see is local. Another word for extrema would be mins and maxes. So we're looking for local, we're looking around certain areas. Where do we have a min or a max? Maybe algebra 2 words like peaks and valleys, right? So for f to have a relative extrema at x equals c, the first derivative either needs to be 0, like that, right? Or it could also be at like a corner. And if I've got a corner or a cusp, then the first derivative is what? D&E, yeah. Okay, so that's where I could have relative extrema. Now I do want you to note, you don't have to have a relative extrema just because the first derivative is 0. For example, if I had something like that, my slope here, yeah, it's 0, but it's not a relative extrema, okay? In order to have a max, then f has got to go from increasing to decreasing, okay? So let's write that. If x equals c is a relative max, then f changes from increasing to decreasing at x equals c, right? Conversely, if x equals c is a relative min, then f is going to change from decreasing to increasing, okay? So let's write that. So good news, we already know how to analyze the increasing, decreasing behavior of f, right? So this strategy is going to be exactly the same as our strategy for finding increasing, decreasing. It's just that our conclusion, what we're looking for, is going to be slightly different, but our process exactly the same as 2 lessons ago. So our strategy for finding relative extrema, well, it's the same as finding where f was increasing or decreasing, which as a reminder was which derivative do we analyze, first or second? We analyze the first derivative and make a number line, right? And then if f changes from increasing to decreasing, I know I found a relative max. If f changes from decreasing to increasing, I know I found a relative min. Okay, example 1, can you write this in your notes, please? F of x is quantity 10 minus x squared. We want to find the relative extrema, so I'm going to analyze which derivative, first or second? We're going to analyze the first, okay? So let's be careful here. F prime of x, notice I do need chain rule because your outer is x squared and your inner is this 10 minus x. So let's deal with that. 2, hold the inner. My new power is 1. Now what's the derivative of the inner function? It's negative 1. So cleaning this up a bit, I get negative 2 times the quantity 10 minus x, okay? So we're going to make a number line here. We want to find our critical points. This is never going to be DNE, so set it equal to 0. And let's make a number line. So negative 2, is that factor ever going to be 0? That factor is only negative 2, so that can never be 0. So my only hope is to set that second factor equal to 0, which gives me a critical point of 10. Okay, and what are we labeling the top? We're labeling the top f prime, okay? So that means I want to come back to this factored form of f prime. And let's see, if I pick a number less than negative 10, like 0, well, I've got the negative 2, and then 10 minus 0 is positive. A negative times a positive is negative. The multiplicity on the 10 is odd, so I'm going to switch my signs there, right? Okay, so what can you tell me about f on that first interval, negative infinity to 10? Is it decreasing or concave down? It's decreasing, okay? And then it switches to increasing. So do I have a relative min, max, or neither at x equals 10? I've got a relative max at x equals, min at x equals 10. See how we went from decrease to increase? It creates that relative min for us. Okay, so for example 2, I'm finding relative extrema, so I'm analyzing which derivative? The first derivative. So go ahead and find the first derivative for me. Any special rules? You do need product, so find first derivative and then hit continue when you're ready to check your answer. Okay, so here's what I got for f prime. This is never going to be DNE, so we do want to set it equal to 0. So let's clean this up, factor it a bit. So let's see here. We've got e to the x as a common factor of this term and that term, right? So if I factor out an e to the x in the first term from product rule, I'm left with 3x plus 6. And then the second term, if I take out that e to the x, I just have a 3. So, and again, I'm going to set that equal to 0. So if I combine like terms in the parentheses, I get 3x plus 9. And we're going to set that equal to 0. Okay? All right, so again, you all need to grow to like e to the x because it's going to make less work for you. We've got two factors. We've got e to the x. Can e to the x ever be 0? It cannot, okay? It's always positive. So that is not going to create any critical points for us. But what about this second factor? Will that ever be 0? Now that'll be 0 when x is negative 3, right? So let's make our number line. And we're putting only negative 3 on our number line. On the top of our number line, we're labeling it which derivative? F prime. So f on the bottom. Okay. And if I pick a number less than negative 3, like negative 4, well, e to the x, that factor, and by the way, I'm coming back here, e to the x is always positive. If I plug in negative 4, I'm going to get negative 12 plus 9, so that's going to be negative. So ultimately there, I get a negative. If I go to where I grabbed the negative 3 from, it's from this factor here, which has an odd multiplicity, so it is going to switch signs there, all right? So what does this tell me about f? From negative infinity to negative 3, f is what? Is decreasing, and then it switches to increasing. So do I have a relative min, max, or neither at x equals negative 3? we've got a relative min at x equals -3, right? Since f changes from decrease to increase, again, it creates that min for us. Okay, so I'm going to force a pause on your screen. Can you please try this one? It's a motion question, but we're going to do it exactly the same way we've been doing the others. So find the first derivative, make a number line for me. Okay, so I've got the answer here. Be very mindful that it told us to only consider positive time values, so I don't need to worry about that -3. If you did, that's fine. You just did more work than you needed to. But we should have gotten that the first derivative is negative from 0 to 2, and then positive from 2 to infinity. So that means you may have put that the position was decreasing from 0 to 2, which if our position's decreasing, we're moving to the left, and the position would be increasing from 2 to infinity, meaning the particle's moving to the right, okay? So when does the particle reverse direction? Well, it reverses direction at t equals 2, right? Because velocity changed signs. So hopefully that sounds a bit familiar. All right, y'all, I will see you next time.